Boolean algebra minimization. For this topic,
Those that
Boolean algebra minimization. For this topic, we are going to learn about fundamental theorems of Boolean algebra.
Theorem number 1. It is called idempotency. This theorem tells us that a variable added or multiplied n number of times by itself will always result in the same variable. That is, if we have a variable a added to itself is equal to a, and if we have a variable a multiplied by itself is equal to a.
Theorem 2 null elements for addition and multiplication. This theorem tells us that it doesn't matter if you have an a plus 1, it will be every time 1. And if you have a times 0, you will have 0.
Theorem number 3. Involution. This theorem tells us about the existence of the inversion of a variable that has already been inverted. That is, if we have a variable a inverted and we then it again, it gives us the variable a. It doesn't matter what expression is inverted twice, the result will always be the same expression.
Theorem 4 absorption. This theorem tells us that if you have a plus a times b, you will have every time a. And if you have a times a plus b, you also will have a.
Theorem number 5. This theorem tells us that if we have a variable a or a inverted b is equal to a plus b, and if we have a variable a and a inverted plus b, this is equal to ab. It's important to mention that if we have an expression similar to those mentioned above, it is only necessary to make a change of variable to use this theorem properly.
Theorem 6. This theorem tells us that if you have a times b plus a times b inverted, you will have always a. And if you have a plus b times a plus b inverted, you will always have a.
Theorem number 7. It tells us that when we have a sum of products like this, the inverted variable disappears in the result. And in the same way, when you have a product of the sums, we can have this variable disappears.
Theorem 8, De Morgan's theorem. This theorem tells us that if you have a plus b all inverted, it's the same to have A inverted times B inverted. And the second part tells us kind of the same. As you can see, this is the same as this. So you will have A times B all inverted will be the same as A inverted plus B inverted.
And finally, the theorem number 9. It is called consensus. Basically, it tells us that we have three expressions like this. In which we have a variable a which is repeated in another expression but inverted, accompanied by other variables b and c, which are together in the third expression. If we have this, the third expression disappears in the result. And for a product of sums with the same characteristics, exactly the same happens. An example: we have this function and the objective is to reduce it to the minimum expression possible. For this, we must apply some of the theorems mentioned above. We can begin by applying postulate number 5b, which is about the distributive property in these two expressions, and the function remains in this way. Then we group these two expressions and factor the term they have in common, which is A inverted. As a next step, we apply theorem 5a in this expression and then apply the postulate number 5b again. We now apply theorem 6a in these two expressions and we only have this result. Now we use theorem 4a in these two expressions and we are left with only this one. We group these two expressions and factor them the term in common and factorize it. We apply theorem 8a by converting the sum into multiplication, and then theorem 8b to convert the multiplication that remains in a sum. We have two variables inverted twice. To change this, we apply theorem number 3 and we have this result. Finally, we apply theorem 8a in this expression and we are left in this way, which is the smallest possible form of the original function.
To prove that the example equation and the minimized equation that we got are exactly the same, we create the truth table over here. We have the 16 possible combinations and with the results, and we have the same results in both of them. In the next video, we're gonna do a physics comproval for this example.